Quality Digest Presents, and I'm Dirk Dusharme, Editor-in-Chief for Quality Digest, and today we are in San Jose, California at the showroom for Evident, where we are going to take a look at a couple of pieces of equipment from Evident, and as usual, we have Rob Bellinger here with us. Rob, what are we going to look at first?
Yeah, glad to be back. It's first our Olympus CIX100 Critical Cleanliness Inspector System. This is our microscope that's geared primarily for counting particles and scanning particles on filters or other kind of devices for cleanliness counting.
Okay.
And this is our latest version of the software, and we added some extra hardware components to the system and some new features in the software as well that I want to talk about. So to start with, we have a standard filter paper put on the stage, and this filter paper has been, purposely designed with some particles on it and some fibers and things like that. So the system's designed to be very user friendly as far as the operation. They'll go through the top of the inspection here on the software. The user can select inspect sample. And everything about the microscope is automated. So you saw the motorized stage moves very quickly, moves to over the spot where the filter is. It allows the operator to select the sample types that they might be running. Right now we're running, it's called an uncovered membrane, a filter. Okay. But we have particle traps and tape lifts that I'll show you in the filter holders here in a little bit. Once they select what they're running, they can acquire overview images.
And so the purpose of that menu you just showed is basically a configuration setup depending on the type of measurement or what type of particles you're looking for, that sort of thing?
Mostly that setting was for the type of holder, so it knows
Okay.
if it's going to be doing a circular scan or maybe a rectangular scan on a tape lift.
Okay.
And in this case, since we selected the membrane, it did a circular scan and created the overview image here for us. And again, the operator, the only interface that they have to do is put the sample on the stage into the predefined holder position and start working through the scan process.
Okay.
At this point, the operator is asked what kind of configuration they're going to run, and this is more the details of telling it what standard they might adhere to. So you can see that they're running to holding to a specific standard. We have ISO 16232 selected here. And the rest of the information about the type of configuration the microscope's going to use. Once they select that, and they might have different configurations for different samples or different parts that they run. Okay. And they'll hit next, and it's going to automatically set up the microscope with all those configurations, switching the magnification to what it's selected for, moving the part underneath the observation and doing an autofocus. Okay. So the operator doesn't have to worry about pushing in sliders, changing focus manually, moving the sample around where they need it. It just drives to that point. And at this step, they're going to load in some of their sample information. Some of these fields on the right here are required fields, like examiner. I'll select my name here. Other fields could be like a part number. Maybe they have a serial number they have to adhere to. What's great about all these fields is they get put into the reports at the end, and they can also be used to search later on because this system is going to capture every bit of data during the scan, and we can go back months later and search by that part number, that serial number, whatever data field.
Or even the operator.
Or by the operator.
Okay. All right.
And it has the way to do statistical analysis. We can say, show me everything that operator's been doing over the past month and see their trends for cleanliness. Okay. By part number, by operator, anything like that. Okay. So these become critical to have the right fields you want to select, and once the operator fills that in, they really just have to hit run inspection. The system's going to go and automatically do a few focus points. Okay. These focus points are autofocusing, and it creates a topography map because filter paper,
Not real flat.
Not real flat.
Right,
it can have
right.
some curvatures
Okay.
and warping on the surface, so we want to try to correct for that the best we can by creating that focus map. After it's done, you'll see it scans very quickly. It'll count the whole particle filter paper, even the large size filter papers, in a minute.
So the focus map is interesting. That basically just speeds things up, so it doesn't have to focus on each and every spot. It just says this is in general what the waviness or whatever of the paper is, and it just kind of makes a, like you said, a focus map, so it doesn't have to focus at every single point. Just speeds it up.
That's right. There actually is a setting if you go into the configuration to tell it to autofocus at every frame. So if you have a really bad surface,
then you might want to do that.
Then it would take a lot longer though, because it'd have to focus at every single frame. So you're talking multiple minutes to scan rather than just less than a minute.
Right, okay.
Using the predefined focus map and selecting multiple points, it creates that topography map to maintain the best focus during the scan it can. And it's much, much faster that way. After it's done, it's going to stop at this point to allow the operator to see if it passed or failed the criterias. They can look at individual particle types here if they wanted to get an idea of what they saw and if they had to go back and adjust settings for some reason. But typically they're just going to work through the flow here at the top and review their results. At the review, they're going to be able to see every single particle that was captured during the scan. So if they select it, since the part hasn't been moved, it actually moves to it on the stage. It shows the location of that particle on the map, and they can look at the sample image where it shows how it defined that particle. They can even zoom out on this. It captures 100% of the entire surface image. So that's already automatically saved in the system. So users don't have to try to keep their filter papers in boxes and store them for a year because they have to keep the data just in case. Everything's digitally captured here, which is great.
And the table at the right, that's just basically the bins of the different size ranges of particle sizes, right?
That's correct. So this standard that we selected to use has these different bin ranges, and it'll tell you the absolute counts, even normalized counts if you had it by, sometimes they take the wash rinse fluid and rinse it over 3-4 parts at a time. So they might normalize their count divided by the number of washed parts.
Got it.
And that is the information they're looking for here. Since we haven't removed the sample, we can also look at the live observation and see the live image of the particle on the screen.
So you can drive right to any particular particle?
Just by selecting it.
Yeah,
If I wanted to go to this particle and look at the live observation, I can see it now. I can even change my magnification and increase it so I can see it a little bit higher magnification. The system will automatically switch and focus, and we can do an exposure correction and see that particle at higher mag. So everything's intuitive for the operator to do a review process here. Why would they need to do a review? Sometimes particles will get split in half and they need to merge them together. Sometimes there's particles that are too close and they get counted as one and they might need to split them. So if you have particles that overlay sometimes on each other, they have to fix that in the review process. So they'll typically review the top 10, 20 particles, and once they've changed anything that they need to, they can even go in the live observation and take pictures and do some measurements of their own of any individual particle, and that gets added to everything at the end. But once the review process is done, they're going to move on to create a report.
And I notice you're just stepping across, it's very simple, you're just stepping across these buttons across the top of the screen.
Yeah, I think they refer to this as the guided workflow. So yeah, starting all the way out to creating a report at the end. The report templates are very basic Microsoft Word templates, so they can select the template they're going to use and hit create report, give it a name, and it'll open up a report template for us. What's great about this, all of the images are going to be put in there, all of the data gets predefined, and all those fields that we filled in on the right get automatically loaded into the report template. The user doesn't have to retype everything in again. So you can see the sample ID, the part number I typed in, my name, the overview image, and then as you go down, it gives you your counts in those bins and all the pictures of the largest particles.
Of the largest particles, so not everything.
Not just every single picture, it'd be too many pages. They usually, right now we're selected to do the 10 largest. And
does it identify whether it's a particle or a hair or does it try to?
Great question. Yeah, you can see here this one says it's a regular fiber.
A fiber.
It's a long narrow fiber. This one's a regular particle because it had a big spot in the center here.
Okay.
So the way that it determines fibers separate from particles is they have to be very narrow.
Okay.
So if they have too much diameter or a big area on them, it'll mark it as a regular particle.
Okay.
And then it can also, there's none here, but it can also detect reflecting particles. That would be something like metal pieces or glass pieces that have a lot of reflection. It'll separately count those. All in the single scan. So it's a unique illumination method on the CIX that determines reflecting particles, reflecting fibers, regular particles, and regular fibers all in one scan.
And it uses a standard type of lighting for this type of measurement, right? Or can you change the lighting depending on maybe what kind of particles you think you might have?
That's a good question. So on this, it's going to have a fixed lighting,
Okay.
because you don't want to have to worry about creating shadow effects on any of your particles.
Okay, got it.
So it's a fixed reflected light, they call it, through the compound lens.
Okay.
And it's LED lighting, and it automatically sets the intensity in the software for you based on the configuration. And it's just a special lighting technique built in. It's a polarized effect to make reflecting particles look kind of bluish in color.
Okay.
And a reflecting particle will get counted as that because it has so many pixels that are bluish in color.
Okay.
So yeah, great questions. And then the operator completes the scan, they go back to the home screen, and they can inspect another sample, inspect multiples, or they can review old results. I'm going to show this real quick. I have some old scans that I did, because one of the new features on the system, if I open this, is when you have really hard to identify particles. You have something like this that's a translucent particle.
Okay.
What I did is I took some PTFE, like plastic, that's very translucent to light, and scanned it. And the system identifies it for the most part, but the operator in the post-processing and the review would have to come in and select all these that are broke apart and merge them together.
Oh, because the system, because it's translucent, it
doesn't see.
Yeah, it doesn't see
enough.
that as continuous. It's, oh, we got two different parts, but an operator would look at that and go, oh, no, that's obviously
Yeah,
one.
the human
piece.
eye can see that and mark
Okay.
it really easily, so they have to do this in the review typically. So what we've done with the CIX100 now is the ability to implement what's called true AI, artificial intelligence. And what we do is we train something called neural networks. We do the training based on a bunch of example images from the particles that they typically see. We create those training labels, train the artificial intelligence to do the decision and mark the particles. So it's not using the standard threshold-based detection, it's using artificial intelligence to detect the shape and the total outline and make the judgment call like the human eye would. So this was a standard way of doing it, but if you look at the other one that captured using the neural network, that same particle is now here, and it links it together completely.
Okay. And this would be done, you would do the scan, and then you would tell it to run this true AI thing.
That's, yeah, it's set up in the configuration. You would select a configuration that's using the neural network file you determined.
Okay.
And after the scan is complete, it's going to detect the particles like normal. Then it processes it through the neural network. Okay. And it takes another minute, hour or two after the scan is complete, and it processes every particle and makes the better determinations if it needs to.
And the training is done by the company who owns the equipment, or Olympus trains it? Who does the training for the AI?
Yeah, great question. The AI training is typically paid and done by the Olympus applications team. Okay. We have the software and the PC hardware that can do that training. Okay. Or the customer can spend the extra money to purchase the license to do the training on site. Okay. And they have to also have the right PC for it to process the neural network training.
Yeah, a lot of data to crunch, and probably takes a
It really comes out to this. If you're running the same kind of particles a lot and you only need one training done, it's cost effective, just pay us to do the training. But if you're running in a lab that's running different samples all the time, and you're going to have multiples that you have to do training, then they pay to pick the software and do the training on their own. Okay. And the CIX software, all you have to do is select the file after the training's done that you're using. Okay. But that's what I wanted to show with this. Some other new features is they launched, like I mentioned earlier, the ability to scan other hardware types. Okay. We mentioned particle traps. That's something like this, where this comes on a tag, and maybe they want to know the cleanliness of an environment. Maybe they're manufacturing something in their environment. They're going to have start dates and put some information on this tag. Okay. They would take this lid off.
Just set it out in the room.
And expose it out in the room. And this is a slightly sticky surface. Okay. And they would let the particles drop on it, and collect that information, take it back to the system, take it off this tab, and put it into our specially designed holder that fits right where the filter holder goes. Okay. And they would scan this and get particle count for what's called fallout in an area.
Okay.
Or they might want to use, rather than running rinse fluid over components, they might have large components and they need to use tape lift. So tape lift is a low adhesion that they can stick on, do sampling on large panels or something like that. And the tape lift can be put into this holder stuck to the bottom of this, and then it magnetizes in place and hooks right into our system.
Okay.
And instead of scanning the circle now, it's going to scan the rectangle and count all the particles on the tape lift.
Okay.
So they can do critical cleanliness testing on larger components, panels, huge component blocks. We've also launched some other filter size holders. Typical holder size is 47 millimeter for filter paper. We launched a 55 millimeter holder for customers that have filtering systems that require the larger diameter.
Okay.
And then there's some other customers like pharmaceutical that use smaller diameters. They have very small flow-through areas that they dissolve components into, and those are 25 millimeters. So that's what this holder's about, and they can place their filter in here and put it on the system. It fits right into the same place. Beyond that, the CIX also has the ability to do its own check system scans. So that's something that is kind of useful to mention. I'll show it here real quick. The particle standard device ships with the microscope, and this is used in place on the stage to check the system's performance at any given time.
So it's a calibration artifact then?
They're not really calibrating it over again, they're just checking
it.
and it checks multiple things, not just calibration, that the particle is 10 microns. It has a lot of different particle sizes on here, down to 5 microns and smaller. And it has to count all those and size them correctly in the scan, but it also has to stitch. This is a really large, the same size as a filter.
Oh, okay.
It has to stitch the whole thing, so it's checking the performance of the stage, the alignment of the system, the intensity of the light, the detection process, everything's checked in a single scan.
Okay, so it's a check just to tell you whether everything's working right, but there isn't necessarily a user available calibration for the system. It just tells you you're functioning properly, you aren't functioning properly.
Very correct. In most cases, they want to lock the standard users out of being able to modify calibrations, but they want them to do a check anytime at certain intervals. Some customers do it weekly, daily, monthly.
Okay.
It really only takes a couple minutes to run the check system scan, and then it puts that check system date in the system here, and it puts it on the reports at the end too.
When the last one was done.
Yeah, verifying your data, it says last system check was done at this date. You see it on the reports, and you know that everything is aligned and running properly on the system. Last but not least, one of the new major features is the advanced microscopy mode. So we have this great microscope, and a lot of labs do just filters, and that's fine, and it's a turnkey system for scanning filters or tape lifts or particle stamps, but they might have the need to run other kind of samples because maybe they're a multi-use lab, and they might want to put on a circuit board or take images on parts or take measurements on those things as well. So they built in the advanced microscopy mode as well, and it's prompted me to insert a real color slider. So I told you earlier, it has this special lighting for when you're looking at reflecting components, it turns them purplish in color.
Okay.
In order to get rid of that feature when you're in this mode to look at true color of everything, we push in this real color slider, just as a simple slider on the nose piece here.
And then this functions as a basic, just general purpose microscope.
General purpose microscope.
Measuring because you can measure and stuff with it, right?
That's correct. You can take measurements, and if we go over here, I can turn live images on. I can see the components on the surface. This is some of the patterns on that particle standard device.
Sure, yeah.
The operators have the ability to take pictures, save them, take measurements. We have a whole host of different area measurements here, point-to-point measurements. They can export those measurements to Excel from here.
Okay.
They can save the images out in any format. And it really takes it a next step further. We have the ability to add any of our material solution modules. So Evident has a lot of capabilities for material solution analysis of metals, grains, cross-section parts for layer thickness. Those solutions can all be added in if the customer needs to use those in their lab as well. So maybe they're also looking at cast iron analysis, and they're putting cast iron parts on here, and they want to run it through one of the solution modules.
Okay.
And the other feature with the latest software version is we can go to our custom software solution group, and our custom software solution can make customized software interfaces in this mode as well. So if a customer has something specific that they need to do, a very specific workflow or a very specific measurement type that's not part of our material solutions, we can go to a customized solution group and write the module for them.
Okay.
So that can be put into the CIX advanced analysis, advanced microscope interface as well.
Okay.
And to go back to normal, the user just hits the home button here, and it'll ask them to remove. Everything's prompted so they don't accidentally leave something in the array. And so once I select this, it'll go back to the home screen, and the operators could start over with all their normal scans.
Oh, cool. Very good. Very interesting. All right, so this was the CIX100 cleanliness. You call it the cleanliness system, or what?
Yeah, Cleanliness Inspector. A lot of people refer to it as critical cleanliness tester.
All right, Rob, appreciate it. Thanks a lot.